Hi, this is video number 4 for Unit 4 in Trigonometry. It's the last video of our graphing trig function unit. And I would like you to have your yellow packet and your purple packet in front of you at this point. The yellow packet is the principal graphs of trig functions packet. You have 2 more graphs to fill in, which is what we're going to do. And the purple packet is your video notes. And we have a couple examples in there as well. If you need to pause while you go get those things, please do so. Otherwise, let's head on into finishing this off, okay? In your yellow packet, the very first graph that you have is sine, and this graph that I have in blue on my screen should already be done in your packet. And you might notice, I would like you to kind of open it up so you can see the sine curve and at the same time have the next page open which says cosecant. And these 2 graphs I put side by side in the packet because they are related. Sine and cosecant are reciprocals, which means that any place that we know the sine function, we can figure out the cosecant function by taking a reciprocal. So for example, right here on my sine curve, sine is equal to 0. And if I take 0's reciprocal, I have a really strange thing happen. I get 1 divided by 0. Can we divide by 0? Is that possible? It actually is not. So on this graph down here, which is your cosecant page, I'm going to put a vertical asymptote at that same location. And this will happen every place that sine is equal to 0. Every place that sine is equal to 0, which is all these places that I'm highlighting in red, at each of those locations, cosecant is going to be undefined because 0 doesn't have a reciprocal. So these are all breaks in the function, which we learned with the tangent and cotangent function are called asymptotes. So there's an asymptote for the cosecant function wherever sine has a value of 0. Another interesting place or series of places on the sine curve would be the hills and the valleys. At the hills, the value of sine is 1. If I try to look at the number 1 and find its reciprocal, flip it over, it's still 1. So every place where sine is equal to 1, cosecant will also be equal to 1. So that would be at these 2 places. Similarly, if I'm looking at the value -1 and I'm taking the reciprocal, that equals -1. So every place that sine equals -1, which would be here and here, cosecant will also have a value of -1. So far what we have is a series of asymptotes with dots that go up, down, up, down, up, down. That's what we've got, okay? There also are some places where sine is equal to 1/2. So if I kind of go in the middle here, you can see that right about here, that would be actually pi over 6. And right about here, that's actually 5 pi over 6. Doesn't really matter. At those 2 places, the value of sine is 1/2. And what's the reciprocal of 1/2? 2. That's right, 2 over 1. So at this same location, the value of cosecant would be 2. And at this same location is right here. So I'm just going right down the graph, okay? At this same location, on the other graph, we'd have a value of 2. Okay, so now I can kind of see that the shape of this graph might go something like this. And similarly, I could take these locations here. Those are places where sine equals -1/2. Cosecant would equal -2. Because that's the reciprocal of -1/2. I'd have something that looks like this. So now we start to see what the periodic nature of this graph is. It's going to alternate between what I would like to call smiley faces and frowny faces. Smiley faces and frowny faces. They look sort of like parabolas. They are not parabolas because of the asymptotes. Parabolas flare out like this, right? They don't have any limiting behavior. This has asymptotes that kind of hold it in check, okay, and limit how wide it can get. So it's parabola-like shape, but not actual parabolas. smiley face, frowny face. All right, on the next 2 pages in your yellow packet, you should see that you already have graphed the cosine function from a different activity that we did. I think we did that together in class, actually. And we're going to do a similar thing to what we just did with sine and cosecant, because cosine and secant are also reciprocals. So any place where cosine is equal to 0, that's going to transfer onto the secant graph. Before I say it, can you tell me how it's going to transfer? What's the reciprocal of 0? Undefined. So that means that each of these locations that I've highlighted with a black circle correspond to a vertical asymptote down here. Vertical asymptote for secant. Okay, all of the zeros for cosine give secant asymptotes. Okay, all of the places where cosine is equal to 1 will also be equal to 1 on this graph. All those hills are right there. And then all these valleys, 2 of them, I guess, are right there and right there. And then we have the smiley face, frowny face then. So the dots that are up above the midline of the graph are going to make the smiley face. The dots that are below the midline of the graph are going to make the frowny face. Notice again that the curves come out and they hug the asymptotes. I don't want any of this kind of business. That is crazy, okay? And I will take points off for graphing like that. That's not accurate. The shape really looks like this. It comes out wide to hug those asymptotes. Okay, so what I'd like to point out is that if I had graphed the cosine curve and the secant curve on the same graph, you'd have something that looks like this. And this is going to be of importance because when we have variations on secant or on cosecant, the way that we're going to end up graphing is by first graphing the reciprocal cosine or sine curve. We'll graph it dotted in the middle, and then we'll base our smiles and frowns off of that. Notice that at the top of a hill, we have a smiley face kind of graph. And at the bottom of a valley, we have the frowny face kind of graph, okay? And that where the graph hits the midline, those are our asymptote locations. Okay, so we should have enough in our arsenal now that we can do some practice problems. I'd like you to flip over to your purple packet. We're going to do 2 problems together based on what we just saw. Okay, so here's a variation problem. Put it somewhere in your purple packet, write down the equation so you know what it is an example of. Okay, and here's an example of a variation on secant, not just vanilla or plain secant, but a little variation on it. Okay, notice here that we have a 1 that's added in front. That's a D value. So this is going to have a vertical shift of 1, period, because secant and cosecant come from sine and cosine, is back to being 2 pi over b. Just the tangent ones that are weird. Tangent and cotangent. Okay, so 2 pi over b, in this case, is going to give us 4 pi. So it's going to be a stretched out graph, wider side to side than normal. And what I'm going to think about graphing first is exactly what I'm given, except I'm going to switch out this secant for its reciprocal. What is the reciprocal of secant? Cosine, you are correct. So we're going to graph this guy first with this information, and then off of that we will be able to graph the secant. Okay, so up 1 is the first task, vertical shift, period of 4 pi. So that means that with my amplitude of 1, I would only get to be halfway through the cycle by this point. Okay, so here's half of a cosine curve. And then it would continue, like, because the shape of cosine is like this, okay? I only can get that much of it in the amount of space that I have. So I'm going to just extend it going backwards. Oh, I just realized I made a mistake over there, didn't I? I went down 2. Oh, no, I didn't. I'm okay. Looked weird for a second. Okay, so amplitude of 1 on both sides, period of 4 pi, vertical shift of 1 based on cosine. Now, take a look at this, and what we actually want to graph is secant. That was actually the problem. So secant is going to have vertical asymptotes wherever the cosine curve crosses the midline. So these are going to be my vertical asymptotes. And wherever there's a hill, I'm going to have the smiley face. And wherever there's a valley, I'm going to have the frowny face. So the part that's drawn in green is actually the answer for this green question. That's how you graph a secant graph. You graph the cosine graph that's related to it, and then you base the secant graph off of it. One more example. This example is going to be cosecant related. Okay. So I know that my related reciprocal function, keep all the numbers the same, and then think, okay, what is the reciprocal of cosecant? That's sine. So we're going to think about this blue function. We're going to say, well, amplitude is 2, and the period is affected by that 4. It's going to be just pi over 2. So in this space right here, this space in here, I'm going to have one complete cycle of sine. So it's going to be very squished in. All right, let's draw this in blue. So start here and end here, middle. Hills are up 2, valleys down 2. Okay, here's one complete cycle. Okay, I'm going to do another one just because I think it's instructive for you guys to see the repetition. Okay, so that blue graph is the related reciprocal function. It's not the question I was asked, because I was asked about cosecant. Okay, but there are 3 cycles, okay? And I know wherever sine hits the midline, which should be here and here and here and here, all these places. Wherever sine hits the midline, cosecant's going to have a vertical asymptote. So there are all these lines. It's kind of like every tick mark and then one in the middle is how it turned out. Okay? All of these guys are vertical asymptotes. After that, we're going to think about our hills and valleys. Okay, so wherever sine had a hill, cosecant's going to have a smiley face. And wherever sine had a valley, we're going to have the frowny face. And so the red parts here are the answer to the question I was asked. Okay, this is answered in red. Okay, the parts that are red are my answer graph. The blue is not part of my answer, it's part of my work. If you were a little confused about these last 2 examples, I suggest that you go back and listen to them again, try to pick up on the finer points, and we will practice some more in class. Thank you so much.